This question is from thermal physics. This is build up your understanding, question number 20, and it is from the book Pathfinder. So let us see what is the question. So question is, there's a thin tube. It is equipped with a valve. So this is a tube, and this is a tube. This is equipped with the valve. It is connected at the bottom of a vertical cylinder. So this thing which you are seeing is a cylinder. There's a heavy piston is suspended from the top of the cylinder. So this is the heavy piston, and this is the top of the cylinder. With the help of a spring, you can see there's a spring, and the space above the piston is evacuated. So you don't have any air here. This is vacuum. If all the air below the piston is also pumped out, so below the piston here, all the air is pumped out, the piston touches the bottom without exerting any force. So this is an important line. Piston touches the bottom without exerting any force on the bottom. That means there is no normal between the bottom of the cylinder and the piston right now in this figure 1. Now an ideal gas at temperature T. So now this figure is introduced. So when you introduce an ideal gas from this valve, because of pressure, piston will start rising. It rises to a height h. Then if temperature is T, right, that is given. Now after that, what we have to find out, what will be the height of the piston over the bottom if temperature becomes 2T, right? So that's the question. If temperature is T, height is h, what will be the height if temperature becomes 2T? So let us see, how do we solve? We can solve this just by drawing 2, 3 free body diagrams. So this is figure 1, when there is no gas. This is figure 2. Now in figure 1, I have assumed, suppose this level is the natural length. So this is natural length. In figure 1, what is the elongation? X0 I have assumed. Here at Kx0 is equal to mg, because there is no contact, so no normal here. Then in figure 2, when you have introduced a gas, that time, let us say pressure of the gas is P. So PA force will act upward other than mg downward. So mg is also acting downward. Now how much elongation is left? Elongation left is x0 minus h, right? This is the elongation only. Okay. So Kx is equal to mg minus PA. Mg is acting, but PA also acts upward. So net force equal to 0 equation. From ideal gas equation, what do we know? Pressure here for this gas is P, volume is how much? Area of cross section is A, and height h. So PH is equal to nRT, PV equal to nRT. So from these three equations which you have written, see Kx0 is equal to mg, this term will cancel with this. Then you get Kh equal to PA, and if Kh equal to PA, if you substitute here, then you get Kh square is nRT, right? I'm leaving this equation as it is here. We will need this again. Now, when temperature becomes 2T, pressure will increase. So when pressure increases, that time what will happen? If pressure increases, now I have assumed that when temperature is 2T, the piston goes to this level. Right? I have not drawn the diagram, but let us assume that piston goes to this level, and this height h1 we need to find out. So what is the elongation left now? This is the elongation left. How much is this? The distance is just x0 minus h1. So spring forces kx0 minus h1. Weight is as it is, and pressure becomes P1. So minus P1. Again, ideal gas equation P1, V1 is equal to nR2T. Now temperature is 2T. So from again these two equations, if you see, you get KH1 square is equal to nR2T. Right? So if KH1 square is nR2T, nRT is KH square, then if you substitute, you get H1 as root 2H. That's the answer. Right? So it's basically a simple question only. You have to just draw the free body diagram according to the conditions given in the question. So that's it. If you have liked this video, please, if you like my analysis, please like this video, and please share this channel with your friends also. Thank you very much. I'll be back with next video. Thank you.